Welcome student to part 4 of double integral in polar coordinate. In this example, we need to evaluate this given integral by changing the question into the polar coordinates. Now, even if the question, he didn't tell me that I need to change into polar coordinates, that's fine. I will know that I need to go into polar coordinate because you see I have this factor x squared and y squared, number square minus x squared or y squared. Those are not an easy integrals to be done. We cannot evaluate e to the power of minus y squared with respect to y. So the next idea, either I reverse the order of integration from y to x, or I need to use the polar coordinate, which is suggested in this example. So here, in order to change into polar coordinate, I need to sketch the graph of this function. So I need to be able to sketch the graph of this function. So what I will do, I'll just write out what I know about x. I know that x is between 0 and 2, and y is between 0 and square root of 4 minus x squared. Now, let's focus on this one. Y is less than square root of 4 minus x squared. Of course, it is positive, so keep in mind that my y is positive. Now, let's focus on this one. Of course, if we square everything, we will get 4 minus x squared. Take the x squared to the other side. This will give me x squared plus y squared less than 4. What is this? Less than or equal to 4. This is the inside of a circle with center 0, 0. Y center 0, 0 because there is nothing with x and y, and radius 2, y2 because square root of 4 is 2. So I need to write the inside of a circle with center 0, 0 and radius 2. But there is a catch here. I have the y should be always positive. So if I do the circle, I need to do the circle only because y should be the positive, and I should look at the inside of the circle. However, I have also x starting from 0. So only this area should be covered. And that's how we sketch the graph of this function. So here 2, and I need only to look at this part here. Now, once I get this part, I need to know what is r is between what and what, and theta between what and what. And I think those are clearly written here. The r starts from 0, and it will go all the way to 2. So here from 0 to 2. And for the theta, start first here, and we will end up here, which means I will start at degree 0, and I will go all the way to pi over 2, which is 90 degrees. 0 to pi. Those are the two pieces of information. Now all what we need to do is we need to write them down here to solve the question. So we have the double integral from 0 to 2, the integral from 0 to square root 4 minus x squared. And then we have this e, which is not an easy one. And now this would be equal to, we change everything into the polar coordinates. So the theta would start from 0 to pi over 2 d theta. The r would start from 0 to 2 dr. Now, remember, we don't forget this factor r here. And now we have to change everything. Now, luckily for us, x squared minus y squared, if we take the minus outside, this will be x squared plus y squared, which is exactly r squared. So what we'll get in the top is negative r squared. And now this is what we get. 0 to pi over 2. Integral from 0 to 2. Here we have r e minus r d theta. This is a calculus 1 question. We have a function up here with its derivative there. So it's a substitution, easy substitution question that we can do here. So the answer will be 0 to pi over 2. If we do the integration, it will be e minus r squared divided by negative half. And this should be from 0 to 2 d theta. If we now substitute what we need to substitute, this will be negative half e negative 4 plus half e power 0, which is 1, so I don't need to write e power 0. I will get this one. Of course, this can go all the way outside. E negative half plus half. And then we have integral from 0 to pi over 2 only d theta, which will be the final answer. Negative half e negative 4 plus 1 over 2. And then we have pi over 2. And that's the final answer for this question. Please write me in the comment if you have any question.